National Electrical Code, Section 110.23 of 3, addresses overhead workspaces and states that equipment shall not encroach into the working space more than 6 inches horizontally. This section may not directly apply to the situation described. Section 110.26 addresses adjacent workspaces and requires that enclosed equipment shall be accessible to qualified persons without removing obstacles or requiring the use of portable ladders. In the situation where a 100 amp bus plug is not enclosed and a 400 amp bus plug is above it, the 400 amp bus plug encroaching into the adjacent workspace of the 100 amp bus plug by 9 inches could create an accessibility issue for qualified persons who need to work on the 100 amp bus plug. To address these concerns, several potential solutions can be considered. Firstly, rearrange the bus plugs. Moving the 400 amp bus plug to a location that does not encroach into the adjacent workspace of the 100 amp bus plug is a viable option. Secondly, install an access panel. Cutting an access panel into the 400 amp bus plug to allow qualified persons to reach the 100 amp bus plug without having to remove obstacles is another possibility. Thirdly, provide a portable ladder. Leaving a portable ladder in close proximity to the 100 amp bus plug allows qualified persons to safely access it without having to climb over the 400 amp bus plug. While the described situation is not specifically addressed in the National Electrical Code, the authority having jurisdiction's interpretation of Section 110.26 is reasonable and should be taken seriously. By considering the solutions outlined, the concerns can be addressed, ensuring the safety and accessibility of the electrical equipment. Understanding the National Electrical Code, or NEC, is critical for electrical installations. The code provides guidelines and standards to ensure safety and proper functioning of electrical systems. When dealing with bus plugs, which are devices used to tap power from a busbar system, specific considerations must be taken into account to comply with the NEC. One of the primary concerns is the accessibility and workspace around electrical equipment. The NEC specifies minimum clearances and working spaces to allow electricians and other qualified personnel to safely install, maintain, and repair electrical equipment. These requirements are designed to prevent accidental contact with energized parts and to provide enough room for workers to perform their tasks effectively. Section 110.26 of the NEC, as mentioned earlier, deals with a workspace around electrical equipment operating at 600 volts or less. It mandates that sufficient access and working space be provided for all electrical equipment. The depth of the working space is determined by the voltage to ground, condition of the location, and whether there are exposed live parts on one or both sides of the equipment. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. The height of the working space must be at least 6 feet 6 inches or the height of the equipment, whichever is greater. In the case of bus plugs, these requirements apply to the space in front of the bus plugs, ensuring that workers can safely access and operate them. When bus plugs are installed one above the other, as in the scenario described, the encroachment of the upper bus plug into the working space of the lower bus plug becomes a concern. The NEC does not explicitly address the specific situation, but the general intent of the code is to ensure that the working space is clear and unobstructed. Therefore, the authority having jurisdiction, or OJ, may interpret the code to require that the upper bus plug does not encroach into the working space of the lower bus plug to an extent that it creates an accessibility issue. The 6-inch encroachment rule, as referenced in Section 110.23 of 3, typically applies to overhead obstructions, such as lighting fixtures or conduit runs, that may reduce the headroom in the working space. While this rule may not directly apply to the vertical encroachment of one bus plug over another, the AHA may use it as a guideline to determine whether the encroachment is excessive. In situations where the AHA raises concerns about bus plug encroachment, it is important to engage in a constructive dialogue to find a solution that meets the intent of the code and ensures the safety and accessibility of the electrical equipment. As mentioned before, one potential solution is to rearrange the bus plugs. This may involve moving the upper bus plug to a different location where it does not encroach into the working space of the lower bus plug. If rearranging the bus plugs is not feasible, another option is to install an access panel in the upper bus plug. This would allow workers to reach the lower bus plug without having to climb over or around the upper bus plug. The access panel should be large enough to provide adequate access to the lower bus plug, and it should be designed to prevent accidental contact with energized parts. A third option is to provide a portable ladder or platform that workers can use to safely access the lower bus plug. The ladder or platform should be stable and sturdy, and it should be positioned in a way that does not obstruct the working space. In addition to these physical solutions, it is also important to ensure that workers are properly trained and equipped to work on electrical equipment. This includes providing them with appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc-rated clothing. Workers should also be trained on the proper procedures for de-energizing and locking out electrical equipment before performing any maintenance or repair work. In conclusion, the installation of bus plugs must comply with the requirements of the National Electrical Code to ensure safety and accessibility. When bus plugs are installed one above the other, the encroachment of the upper bus plug into the working space of the lower bus plug may create an accessibility issue. In such cases, potential solutions include rearranging the bus plugs, installing an access panel, or providing a portable ladder. It is important to engage in a constructive dialogue with the AHA to find a solution that meets the intent of the code and ensures the safety of electrical workers. Furthermore, proper training and the use of appropriate personal protective equipment are essential for working safely on electrical equipment. By following these guidelines, you can ensure that bus plug installations are code compliant and safe for all personnel. Let's delve deeper into specific sections of the NEC relevant to the installation and maintenance of bus plugs, while continuing to avoid any conversational or introductory elements. Section 110.16 Flash Protection requires that electrical equipment, such as bus plugs, that are likely to require examination, adjustment, servicing, or maintenance while energized, be field marked to warn qualified persons of potential electric arc flash hazard. This marking must be located so as to be clearly visible to qualified persons before examination, adjustment, servicing, or maintenance of the equipment. The marking should include the nominal voltage arc flash boundary and the personal protective equipment, or PPE, required. This requirement emphasizes the importance of assessing the potential arc flash hazards associated with bus plugs and providing adequate warnings to personnel working on them. Arc flash is a dangerous phenomenon that can occur when electrical equipment is inadvertently short-circuited. The resulting explosion can cause severe burns, injuries, and even death. Therefore, it is crucial to follow safe work practices and wear appropriate PPE when working on or near energized bus plugs. Section 240.4 Protection of Conductors specifies the requirements for protecting conductors against overcurrent. Bus plugs typically include overcurrent protection devices, such as fuses or circuit breakers, to protect the conductors and equipment downstream from the bus plug. The size of the overcurrent protection device must be coordinated with the ampacity of the conductors being protected. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specified conditions of use without exceeding its temperature rating. The NEC provides tables and guidelines for determining the ampacity of conductors based on their size, insulation type, and installation method. It is important to ensure that the overcurrent protection device in the bus plug is properly sized to protect the conductors and equipment downstream. Overcurrent protection devices that are too small will trip unnecessarily, interrupting power to the load. Overcurrent protection devices that are too large will not provide adequate protection, potentially leading to conductor damage or even a fire. Section 368 Busways provides specific requirements for the installation and support of busways, which are the structures that bus plugs connect to. Busways must be securely supported and installed in a manner that prevents mechanical damage. The NEC specifies the maximum spacing between supports for busways, as well as the types of supports that are permitted. Busways must also be protected from physical damage and corrosion. Busways that are installed in damp or wet locations must be identified for use in those locations. The NEC also provides requirements for grounding busways to ensure that they are electrically safe. Grounding is the process of connecting electrical equipment to the earth to provide a low impedance path for fault current to flow. This helps to protect personnel from electric shock and to prevent damage to equipment. In addition to these specific sections, there are other general requirements in the NEC that apply to the installation and maintenance of bus plugs. These include requirements for wiring methods, grounding, bonding, and overcurrent protection. It is important to consult the NEC and other relevant standards to ensure that bus plug installations are code compliant and safe. Regular inspection and maintenance of bus plugs are also essential for ensuring their continued safe and reliable operation. Inspections should be performed by qualified personnel who are familiar with the NEC and the specific requirements for bus plugs. During inspections, the bus plugs should be visually inspected for any signs of damage, such as cracks, corrosion, or loose connections. The overcurrent protection devices should also be tested to ensure that they are functioning properly. Any deficiencies that are identified during inspection should be promptly corrected. Maintenance tasks may include tightening connections, cleaning contacts, and replacing worn or damaged parts. It is important to follow the manufacturer's recommendations for maintenance procedures and schedules. By following these guidelines, you can ensure that bus plug installations are code compliant, safe, and reliable. This includes addressing potential encroachment issues, providing adequate arc flash protection, properly sizing overcurrent protection devices, and performing regular inspections and maintenance. Remember that the National Electrical Code is a living document that is updated regularly to reflect changes in technology and best practices. It is important to stay current with the latest edition of the NEC and to consult with qualified electrical professionals when necessary. Consider how grounding and bonding is also an important factor to consider. Grounding and bonding are critical aspects of electrical safety that help to protect personnel from electric shock and to prevent damage to equipment. In the context of bus plugs and busways, grounding and bonding ensure that any fault current will have a low impedance path back to the source, causing the overcurrent protection device to trip and de-energize the circuit. Section 250 of the NEC covers the requirements for grounding and bonding. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of different metallic parts of the electrical system together. The purpose of grounding is to provide a reference point for the electrical system and to limit the voltage on exposed metal parts. The purpose of bonding is to create a low impedance path for fault current to flow back to the source. Busways must be grounded in accordance with the NEC. Typically, this is accomplished by connecting the busway enclosure to the building's grounding electrode system. The grounding electrode system consists of one or more grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes that are connected together to form a low impedance path to earth. Bus plugs must also be bonded to the busway enclosure. This ensures that any fault current will flow back to the source without creating a voltage difference between the bus plug and the busway. Bonding can be accomplished by using bonding jumpers, which are short lengths of wire that connect the metallic parts together. The size of the bonding jumpers must be sufficient to carry the maximum fault current that is likely to occur. In addition to grounding and bonding, it is also important to ensure that the electrical system is properly insulated. Insulation is the material that surrounds the conductors and prevents them from coming into contact with each other or with grounded metal parts. The NEC specifies the types of insulation that are permitted for different applications. It is important to use the correct type of insulation for the environment in which the bus plugs and busways are installed. For example, insulation that is exposed to moisture or chemicals must be resistant to those substances. Regular inspection and testing of the grounding, bonding, and insulation systems are essential for ensuring their continued effectiveness. Grounding and bonding connections should be visually inspected for any signs of corrosion or damage. Insulation should be tested for its dielectric strength, which is its ability to withstand voltage without breaking down. Any deficiencies that are identified during inspections or testing should be promptly corrected. In summary, grounding and bonding are critical aspects of electrical safety that help to protect personnel from electric shock and to prevent damage to equipment. Busways and bus plugs must be grounded and bonded in accordance with the NEC to ensure that any fault current will have a low impedance path back to the source. Regular inspection and testing of the grounding, bonding, and insulation systems are essential for ensuring their continued effectiveness.